Hey everybody, today I'm going to show you a graphical interface that I devised which is used for setting an attack threshold. This kind of thing comes into play whenever you need to accurately identify the onset of a sound. For example, finding a particular index in a buffer which contains recorded sound, or maybe triggering computer-generated sounds simultaneously with live user input. It's important to be able to set a proper threshold since the acoustics of one space can change drastically from one space to the next. Or it might be the case that the microphone or microphones might be positioned differently, closer or further away compared to a previous setup. Right, so let's get started. First thing we want to do is name the server, like we usually do. And we'll wrap everything in a wait for boot function. That way we can write our code and just highlight everything, compile it, and the server will boot, and then it will run everything we've done. We'll start by making a synth def, call it thresh test, and this synth def will be used for instantiating a synth. Once on the server, it'll send amplitude data from the server to the client, and that it'll send this data back to the client, and that'll be used to modify and update our graphical user interface. So we need a threshold argument, and we'll default it to minus 30 decibels. We need 3 variables, one for the sound coming in, one for tracking amplitude, and one as a trigger, which will be 1 whenever the amplitude crosses the threshold and 0 otherwise. There's our sound coming in. There's our amplitude, and we'll convert it to decibels since our threshold is in decibels. We'll also use a K2A to convert it to audio rate for accuracy reasons. And trig is 1 whenever amplitude is greater than or equal to threshold. So that's what that line looks like. It'll be 0 whenever amplitude is less than threshold and 1 otherwise. Last thing we're going to do is a send reply, which is one of the unit generators that sends values from the server back to the client. We'll send 50 values per second. We'll use trigval as a name, and we just want to send trig. And that'll do it for our synth def. Okay, so next let's make a window. This is the window. It's going to have all our graphical user interface stuff. Give it a title, give it some bounds. Background color, and we'll do a function to be evaluated when the window's closed. We'll just free everything off from the server, just so we don't get any weird error messages. Okay, so the first thing we're going to do, we're going to put into this window a number box, which we'll call number box. And this number box will just display the current threshold value in decibels. Alright, and then a bunch of attributes here. Set the font. Nice and big. Default value will be consistent with the synth def's default value for the threshold. And it needs an action. So the first thing we'll do is we'll pass the number box itself into the action function as an argument. So as with GUI objects that have actions associated with them, there's always a risk of an infinite loop. For example, if object A's action calls object B's action to be evaluated, and object B's action called object A's action to be evaluated, this will crash the program because you'll just hit an infinite loop of commands. So it's good to have a mental hierarchy of objects, of GUI objects. And so I'm going to put this number box at the top of the hierarchy, and by that I mean other objects can call, the number box, set the number box's value, or they'll call the number box's action, but the number box itself won't call any actions from other objects. As for now, we'll change this in a second, but for now let's just post the value of the number box to the post window. And since this is the top of the hierarchy, we're going to use this object, the number box, to set the threshold argument for our synth. And rather than just blindly saying, okay, synth.set thresh equals numberbox.value, we want to actually make sure that the synth has been instantiated, that it's actually on the server. So we're going to use a conditional statement here. We haven't named anything thresh test yet, so this is still nil. But I'm going to use this environment variable to as the name for the instance of the synth once it's created. So we want to know, okay, has this been created? So in other words, if it's not nil, then we can evaluate. We can see, okay, can we set the synth argument? But we also need to do another conditional. We want to know if the synth, once you create a synth, it's no longer nil, but whether it's actually on the server is a different question. So we want to know, is thresh test group actually a group? If it's not, it'll be nil. It's either group or the nil class. So if it is group, then we're going to actually set the thresh argument of the synth to the value of the number box, because our conditionals have ensured that it is safe to do so. And if it's not on the server, then do nothing. And that's our first conditional, or first statement for the outer conditional. If tilde thresh test is nil, that means it hasn't been created at all yet. That variable is unused. So again, do nothing. Okay. Right. And in fact, that's the end of our action function and the end of defining our number box. Okay. So what next? Number box by itself is okay. I mean, it's not a great interface. You can click and type into it, but there's a better way to interact with it. So I'm gonna make a knob, and this knob is gonna be used to control the values in the number box. And knob actually expects an array of colors. Okay. Default value, we'll just take the number box's value, since number box is at the top of our hierarchy. Got to convert it to amplitude, because the knobs think from 0 to 1. So we're going to take decibels, convert that to amplitude. And of course this needs an action as well. And here's the knob we're passing in as an argument. And all we're going to do now is just set the value of the number box to the value of the knob converted to decibels. And it also calls number box's action, which at this point will post the value and then test to see if the synth has in fact been created yet. And right now it hasn't. Okay, so that's basically all we have so far. So I'm going to close out the wait for boot function and see what we have. Okay, looks like I got... Oh, I see. I didn't put the window in the front. Got to call the front message on that. Let's shrink this down a little bit. Try it again. There we go. Okay, so our knob seems to be working. It's updating the value of the number box and posting it and evaluating the conditional, which at this point in time returns nothing. And right, we can change the number box, but that doesn't reflect the changes in the knob. So in case the user wants to input stuff directly into the number box, let's modify the number box's action. So in addition to posting and our conditional, we want to keep these two objects synchronized. I mean, of course we have two options. We can either, set the number box to be non-editable, by the user. You can't directly edit it, or you can allow the user to edit it. But like I said, as the code stands now, those changes aren't reflected in the knob, and in fact you actually saw that. So we'll add a new line to the action function of the number box, essentially calling the value, and not value action, because that will create this infinite loop I discussed. So we're just going to set the knob value equal to the number box value converted to amplitude. And let's try it again. So our knob still works, and now if we move the number box around, it will adjust the knob. I'm just clicking on the number box and dragging up and down. So yeah, that looks like it's working. So the maximum is 0 decibels, which is good, and we've got a lot of resolution up in the high range of amplitude or decibel values here. But once we get down here, since we're setting a threshold, we might actually want a high degree of resolution down here as well. Like if you want to get down to 40 or something, and you can always type it in, but we want this interface to be really sleek and efficient. So here's what I'm going to do. I'm going to make a new object here. It's going to be a slider, and it's going to set the maximum value of the knob. So when the slider's value is low, we'll still have the normal physical range of the knob, but it'll cover a smaller range of values. So instead of, let's see, what's the lowest value here? Is it negative infinity? Yeah, negative infinity. So instead of negative infinity to 0, it'll be negative infinity to the current value of the slider. So, maybe that's minus 60 decibels or minus 30 decibels, something like that. And of course, once we make this object, we're going to have to go back and modify the action functions of the knob and the number box in order to reflect this new addition, this new functionality we're building. So we'll call it maxval slider. And let's make an easy slider. Yeah, easy GUIs take a lot of inputs. So we need a control spec to specify the range and behavior of the slider. We'll have it go from negative 90 to 0. It'll be linear, step size will be 0.1, default value will be 0, and we don't need any unit label or anything like that. Okay, and then after the control spec comes the action function. So we'll pass the slider in as an argument like we always do. And let's see, so this is just going to set the number box equal to, let's see, we want the knob value multiplied by the slider value converted to decibels. Nope, sorry, converted to amplitude because it's already in decibels. And once we multiplied those, convert them back to decibels. And right, so it'll set that value, it'll set the number box equal to that value and call the number box's action. Okay. And right, we need a few more arguments for our easy GUI. Don't evaluate the action. I just have these written down. It's just a lot of them, a lot of numbers to put in here. Want to be horizontal. Okay, etc., etc. It's all in the help file. Okay, and let's set some colors. And the font. Okay, so there's our slider, and we've got to go back and edit the knob and number box functions. So, see the knob, right, so the slider and the knob both call value action on the number box. See, the knob calls value action, and the slider calls value action. And we want these to be consistent with one another. We want the effect of the slider to be transmitted through both GUI objects. The knob needs to know about the slider, or the knob has to take into account the slider's value when it sets the number box value. We're going to multiply the knob value by the slider value with the correct amp decibels conversions. So actually, I think it should just be the same as, yeah, I think it's just exactly this. Yeah, this line right here. Right. Just the exact same thing. If you change the slider, it should change the number box. If you change the knob, it should change the number box. And it has to do with multiplying these two values together in the following, in this way right here, which is highlighted. Okay, so that's the change we need to make to the knob. And the number box is a little trickier because we've set it to be synchronized with the knob. So, like, you know, the knob calls the number box, or the knob sets the value of the number box, but then the number box also sets the value of the knob. So this is the step that needs to be changed here. Right, we've decided to keep those synchronized. So because of the max value slider, when the number box calls this line here, knob.value, we need to compensate by dividing the number box value by the slider value. So number box dot value, yeah, in decibels to amplitudes, divided by right, convert them both to amplitude, divide one by the other, and set it equal to the knob value without calling the knob's action. Okay, I think that should work. Except, oh, this needs to be changed. Knob is not going to know what slider is because that's not defined within the action function. This needs to be max val slider. Okay, I'm going to save this. And let's try it out. Okay, no errors. Looks like we still have the same functionality here. So let's try modifying the knob maximum. Actually, let's turn this knob up here. Yeah, and so now, since the knob is at its maximum, the number box and the slider will always be the same. Okay, so if we set the knob maximum to something like, I don't know, let's type it in directly, -50. Yeah, so now we can, you know, hang out in this really low decibel range, and we have a good degree of resolution. But we can always jump right back to the normal sort of default resolution, where we have up in these high decibels here. Okay, anyway, so it looks like everything's working. That's good. Which means we can now move on to the slightly easier stuff. Okay, so let's see. Let's make a button, which it'll have two states, and it will be used for creating or instantiating the synth on the server and freeing the synth. So we can start the test and stop the test. All right, so states, which expects an array of arrays. Start test and stop test. And in addition to states, we need action. All right, so this button's action. Here's the GUI instance as an argument. And we'll just use a case statement here. In state 0, we want to free the synth. And in state 1, we're going to instantiate the synth. And of course we need to pass the number box value in as an argument for the thresh argument. Do that right. Number box.value. Right. Close out the case statement, and that's the end of our button function. And let's also set the font. Good, it's our button. Excellent. Okay, so we want something to pop up when we actually cross this threshold, so I'm going to make a text view. It'll just be a piece of text, static text that we'll use this in a drawing function on the window later. So we'll have a visual cue for when we cross the attack threshold. And to start off, you won't be able to see it because we only want to see it when we cross the attack threshold. So it'll be invisible upon creation, and it also will not be editable. It'll have the string received, set the font like we've been doing. Black checks, oops, no semicolon there. And last, okay. And just to be extra fancy, I'm gonna make a rough equivalent to a max MSP bang, and I'm gonna do that by defining a drawing function for our parent window W. And this is just basically going to involve the pen class, which is a great class and really the primary tool for visuals, for drawing on windows in SuperCollider. I won't go into a lot of detail here, but it's all in the help file, so you can look up the pen help file if you want to know more. We're going to call the drawHook method on the window. Just an argument. You can pass in an argument to drawHook functions. I don't think I'm going to use it here though. Okay, so I set the fill and stroke color and the width, and then we actually draw an arc. Add a point with a radius and starting and ending radians, I think that's what that is. Then draw it, and in order to see those changes, we have to refresh the window. Okay, So that's going to set up our little circle, our little max MSP bang, and also a receive text view. And the last thing we need is an OSC responder. This will be sort of the middleman between the server and the client. The server is going to be sending via the send reply unit generator. It's going to be sending amplitude values to the client, and we need an OSC responder to pick those up and perform a function which affects the graphical user interface. So I'm going to call it OSCR1, and actually let's remove it in case we compile this code several times. We don't want OSC responders to just sort of pile up in empty space there. So first remove it and then create it. And trig val, like we created in our synth def, and this function expects 3 arguments: time, responder, and message. And the value we're interested in is the 3rd index in the message argument. Message is going to be an array of 4 values. So the 3rd index is our trig variable from the synth def. And so we're going to use a conditional here. We want to know if that trigger is 1, meaning if the amplitude has crossed the threshold, then we're going to perform a function. And this is going to be a routine. And it's going to be 2 quick redefinitions of the drawing function for the window, and we're also going to briefly make the received text view visible and then make it invisible again. So here's our new draw hook. Fill color is going to be green. It's going to flash green. The width stays the same. Not stroke fill. We want fill stroke. Okay. So that's our first draw hook. Refresh the window. And make our text visible. So it's going to briefly, the circles we made is going to flash green, and you're going to see the word received. And so we'll do that for 1/10 of a second. And then we need to undo it. So I think the quickest way to do this is just copy paste and change the fill color back to what it was initially. And that's really all we need to do. And of course, refresh the window. And make the text invisible once again. Play it on the app clock. Okay. That's the end of our conditional statement. And that's the end of our OSC responder, so we want to add that. And that is it. I think that's all we need. So I'll save this once more, and let's see if it works. All right, parse error. Let's see. I bet I put a semicolon. Yeah, that's right. I put a semicolon there, and I didn't need one. Actually, I was another parse error near the routine. Comma, that's what it is. Comma after the conditional statement. All right, only 2 errors, not too bad. All right, so this still works. You can set the maximum, 51.6. Yeah, this is looking pretty good. Alright, so I'm going to start the test. And let's see, did we add our synth here? Yeah. That little red box says thresh test. So our synth is sitting on the server and listening. And right now our threshold is set to maximum amplitude. So we're not picking up anything. I mean, my voice right now is too quiet for this. So what I'm actually going to do is turn on a metronome. Okay. Okay, hopefully you guys can hear that. And let's start turning this down and see when we start getting data. Okay, all the way at the bottom here. All right. We're getting some, but we're not getting everything. So let's take the maximum, the knob max down to something like, I don't know, 30-ish. So if you watch this now, we'll get some of these. Okay, well, we're actually getting most of them. So that's pretty good. But let's turn it down. If we make it too low, you'll see what happens. That's still pretty good. Way down here, you can see we're just getting tons of triggers because, you know, this value is so low that the system is hypersensitive. So even, you know, minor disturbances in the air are being picked up. And of course, if we bring this all the way up, we get absolutely nothing. So we've designed this so, you know, you have enough flexibility to be able to find a nice threshold. Right. Cool. Okay, let's get rid of that. Right, and so it's still listening to my voice, so it's picking up me talking, and we can just hit stop test, and it's done, right? And you can actually look back at the server, and you can see our thresh test synth is gone. And now we've got a perfectly usable value, which I think if we just do, we hit number box dot value, it'll give us, yeah, there's our value. So there it is, ready for the using. And just to show you how you can incorporate this into your own code, I have a looping environment that I've been working on, and I just recently added it in. It takes a few seconds to load up, but you'll see it in the corner. Right. So there's this looping environment I have, and you can see up here in the corner, I've got the same sort of thing I was just working with. You know, you've got, you can set this. I mean, this hasn't been converted to decibels. This is actually from 0 to 1, where 1 is, you know, 0 decibels and so forth. But same sort of stuff. And let's see, I can start the test, and should be listening to me. Yeah. So here we go. And once I pick a value that I like, I can click use this value, and the system will reboot. And the last thing it posts is right here. You can see it says current attack threshold equals whatever. And then you're ready to, you know, begin the piece or whatever you want. You know, you can, that sort of stuff. Right. So that's about it. That's what I came up with for an attack threshold tester. You know, I've showed you if it's too high, if it's too low, it's, you know, you don't get enough triggers or you get too many. And you can see that you can take the basic idea of what we've done here and build it into a larger system or a larger piece of code. Right, so I'll include a link to the attack threshold code in the video description. And as always, comments, questions, thoughts are always welcome. You can post on the video or send me a private message. So that's it. Thanks for watching.